Hello, we are
In
from
this
Lawrence
occasion,
Group.
we want to discuss
We are
about
Vina,
AIDS, an
Devi, and
invariably fatal
Victor.
disease.
Want to explain about is AIDS an invariably fatal disease?
Anyway, what is AIDS? Is it similar with HIV?
Not really. AIDS is a stage of HIV infection. The host reaches the AIDS stage of the infection either when one of the more infections characteristic of AIDS develop or AIDS clinical AIDS, and the T4 cell density falls below 250 cells per millimeter cube.
Then, is AIDS a fatal disease?
Yeah, start from HIV infection is dangerous. It fatally weakens a host immune system. Before we continue, let's watch this video first.
AIDS is caused by the human immunodeficiency virus, HIV. This is an enveloped virus. The envelope is derived from the host cell membrane with viral glycoproteins such as GP120 and GP41 inserted into the membrane as the virus leaves the cell. The core is composed of P24 capsid protein, and the P17 matrix protein helps maintain viral structure. Inside the core are two identical copies of single-stranded RNA viral genome and three enzymes, reverse transcriptase, RT, protease, PR, and integrase, IN. To establish infection, HIV must first attach to its host cell. Attachment occurs by interaction between GP120 on the surface of the virus and the CD4 antigen receptor on the surface of the host cell. In addition to the CD4 receptor, there must also be a co-receptor on the host cell. The co-receptor differs for different host cell types. In T lymphocytes, the co-receptor is called CXCR4, whereas on macrophages, the co-receptor is called CCR5. After attachment, the viral envelope and host cell membrane fuse, resulting in entry of the virus into the cell. Once the RNA is released into the cytoplasm of the host cell, reverse transcriptase makes a DNA copy of the viral RNA genome. As the DNA is being formed, reverse transcriptase degrades the RNA strand. A complementary DNA strand is then added by the reverse transcriptase, and the ends of the resulting double-stranded DNA segment are joined non-covalently. Treatment with nucleoside analogs or reverse transcriptase inhibitors interferes with these steps. The resulting circular DNA is then moved to the nucleus and inserted into the host cell chromosome by the viral integrase, IN, enzyme. The integrated viral DNA is now referred to as proviral DNA. Following integration, the proviral DNA may remain dormant, or with host cell activation, RNA may be synthesized from the DNA, yielding messenger RNA and viral genome RNA. Viral messenger RNA is translated, yielding viral enzymes and structural proteins. Some of the functional proteins are formed by cleavage of a long polyprotein by the enzyme protease. Protease inhibitors interfere with this step. GP41 and GP120 are inserted into the host cell membrane, and the structural proteins surround the viral RNA to form the core. Finally, the virion is released by budding.
However, we can measure the survivability of hosts that develop AIDS. We can use differential equation. Let SE, a survival model for a cohort of AIDS patients, postulate that AIDS is not a fatal condition for a fraction of the cohort. K is the probability of dying per unit time at time t. NST is survival fraction. Using those variables, we have the rate of ST or differentiate of ST equals minus K times ST minus SE. Using separable equation strategy, we can get ST equals SE plus C times e power minus KT. Then, using the initial value, when t equals 0, then st equals 1, we can get c equals 1 minus se. Let's substitute the C equals 1 minus SE to the family of solutions. Then we get ST equals SE plus 1 minus SE times E power minus KT. This is the model of survival fraction of AIDS patients. See, the T parameter is appearing. Then analogous to the half-life in radioactive nuclear decay, we can get the T average equals K power minus 1 and the T half-life equals ln2 per K. T aver is the average survival time and T half is the time required for half of the cohort to die. Using the T average and the T half, we get the new model of ST with new parameter.
Then, what can we do with the model?
We can use it for measure the immortal fraction and the survival time of AIDS patients. Look at this data. This data of 157 Marylanders who developed AIDS in 1985. If we input to the model, we can get the SE equals 0.0665 and the T half equals 0.666 and the T average equals 0.960. This is another data. This is data on the survivability of 1,415 Zenofudine-treated HIV infected. And the data show like this following. Which is T equals 0 is redefined to mean the moment of T4 cell density of a host falls below 10 cells per millimeter cube. Such like before, we input the data to the model of ST. And we get SE equals 0 and T half equals 0.878. Equivalently, the T average equals 1.27 years. Now, let's compare the both condition with and without zidofudine therapy. The immortal fraction value here is clearly an upper limit to its true value because maybe there are patients that change their name and die and not be not here. From this calculation, we get the range of SE is between 0 until 0.0665 and the T average range between 0.96 years until 1.27 years. Thus, the percentage of people for whom AIDS is not fatal disease is less than 6.65% and maybe 0.
Created using Powtoon.
From the questions, number 1, we can make the mathematical form to be dst over dt is equal to minus k times st minus se. Then, since st is equal to a to the power of minus kt, so we substitute the value of st to be d a to the power of minus kt over dt, then equal to minus k times a to the power minus kt minus se. Then, so that the value will be like this: minus k times a to the power a kt equal to minus k a to the power of min kt plus kse. Whereas kse is equal to 0, then se is equal to 0 as well. Then st is equal to se plus 1 minus SE times A to the power of T per T average. Then ST is equal to A to the power of min KT equal to SE is equal to 0 plus 1 equal to 0 times A to the power of minus T per T average. Then because minus K times T is equal to minus T per T average, so we can make the equation become like this: A to the power of minus T per T average is equal to A to the power of minus T per T average. So the equation is similar. Okay.
Action.
So the question number 2 is, what fraction of the core survive 5 years after age diagnosis? From the question, we know the value of K is equal to 5 years. And the value of T average, we already given the value of T average is equal to 6.4 months. Then the equation is ST is equal to A to the power of minus K times T. Since A to the power of minus K times T is equal to A to the power of minus T per T average, so we just substitute the value of K and the value of T average. So A equal to A to the power of minus 5 over 6.4. So we got 0.458 and something. Udah.
Okay, and then next is number 3. From the question, we can write ST to reach the value of 0.5 is defined as the survival half-life and denoted by T half. And then this one, based on the equation, we can see ST is equal to EXP minus K times T. It means we can write in E the power to minus K times T. For T, we can know is 0.5. And then for T, we can know T half. So we can write 0.5 is equal to E the power to the power of min K times T half. So this is it can be ln 0.5 is equal to min K times T half. And then we can know what is K. K is minus ln 0.5 over T half. So we can answer the question in part A is st minus a is equal to a the power of min k times t. St is equal to a, since we already know the value of k, which so we just substitute it. A the power of min ln 0.5 per t per t half times t, and then st is equal to a the power of minus ln 0.5 times the power of t over t half, and then st it can be 2 the power of t per t half. From this we can know the value of e the power of minus k times t is equal to 2 the power of minus t per t half. From this we can change the e the power of k times t become e minus t per t average is equal to 2 the power of min t per t half. And then for B, in part B, we can know E the power of min t per t average is equal to E the power of ln 2 the power of min t per t half. E the power of min t per t average is equal to E the power of min t times ln 2 per t half. Since the left side is e the power of and the right side is e the power of, so we can write it become min t per t average is equal to min t times ln 2 per t half. We can divide with t for the both side, so we can get min we can divide minus t for the both side, so it can be 1 per t average is equal to ln 2 per t half. So we can in bahasa Indonesia dikali silang, so we can do it. Then t half is equal to ln 2 times T average.
Go.
Okay. And then for number 4, we already know based on the equation %10 of lung cancer who survive survive 5 years with no evidence, and only 14% of lung cancer will survive 5 years after diagnosis. Okay. Then we can find for ST is equal to, since the only 14% of lung cancer, we can write n minus 10% of lung cancers. 14% minus 10% of lung cancer is 4%. So we can write 4% over 100 minus 10 of lung cancer that survive 5 years with no evidence, minus 10% times 100%. ST 4% over 90% times 100%. So we can know the result is 44.44%. Next, we can find for ST is equal to E the power of minus K times T. Since we already know for T is 5 years, we just substitute it. 5 as 5 is equal to E minus K times T. Since T is 5, we just substitute it. So E the power of minus 5K. For this, we can find for K. K is equal to ST 44.44% per E the power of 5. So the result of K is 6.6. Then we can substitute K as T is equal to A the power of minus 6.6 T. After this, we can find ST is equal to SE plus 1 minus SE times E the power of min k times t. We can substitute t is 5 years as 5 years is equal to SE plus 1 minus SE times A minus 6.6 is K times 40 is 5. Then SE plus 1 minus SE times A the power of minus 33. And then we can substitute it, this one, become 0.14. Why 0.14? Since we already know the only 14 persons of lung cancer. So we can continue it. It becomes SE plus 1 minus SE times E the power of minus 33. And then we can do,
Yeah.
so we can do subtraction for the both side. 0.14 minus minus E the power of minus 33 is equal to 1 minus E the power of minus 33 times SE. So we can find SE is 0.14. We can rewrite the general formula become ST is equal to 0.15 plus 0.86 times E the power of minus 6.6 t. This is the result.